Hi, I'm Zoe, and I'm going to be doing the AP Calculus AB 2008 FRQ Question 5. The question starts out with, consider the differential equation dy over dx equals y minus 1 over x squared, where x is not equal to 0. Part A gives us a grid and asks us to draw a slope field. This is pretty straightforward, and we can remember that all you need to do is plug in the x and y values of each point into the differential equation given, and that is the slope at each point. To begin, we know that x cannot equal 0, so any points at x equals 0 will not have anything drawn on them. Next, we're going to see everywhere that y equals 1 is going to leave the slope equal to 0. You have to skip the x equals 0. And you get a point for those 0 slopes individually. Next, you plug in all the other individual points. That's going to give us a slope of 1 here, 1/4 here, which we're just going to make a little less steep, and then a 1 here. Because it's x is squared, they're all going to be positive. And down here on the bottom, we're going to have a -1, another -1, and a -1/4, which will again be a little shallower. For the slope fields, you only get points for the 0 slopes and then another point for the rest of the slopes. They're not looking so much to see how steep it is, because sometimes that can be really difficult to tell just by eye. And so what the graders are really looking at is whether or not you have the positive and negative correct. You can also tell that there's a little bit of symmetry here, and that can help you drawing as well. Part B says, find the particular solution y equals f of x to the differential equation with the initial condition f of 2 equals 0. The first step is to separate the variables, and that gives us 1 over y minus 1 dy, which is equal to 1 over x squared dx. Then we're going to take the antiderivative of both. You can just add the plus c over to the other side. Because the plus c represents an unknown constant, subtracting the plus c from the y side from the plus c from the x side gives another unknown constant, which we can still just represent as c. So instead of doing the extra work, we can just write the plus c on the x side after integrating. We then raise everything to e, and we can rewrite it as e to the c times e to the -1 over x. And since we know that e to the c is a constant, when we take the absolute value bars, we can have the e to the c absorb the plus or minus, and as long as we define k as plus or minus e to the c, we can just write it like this. We can then plug in our initial condition, which says f of 2 equals 0, and that gives us -1 equals k e to the -1/2. We can then solve for k, which gives us -e to the 1/2. If we then plug in our k to the equation that we had right before solving for k, we can get y minus 1 equals -e to the 1/2 minus 1 over x. We then solve for y, and that is our final equation. The key points in this problem is to remember to separate the variables first and show that step, as well as not forgetting the constant of integration, or the plus c, that you always have to have after taking the antiderivative of something. And that's really it. It's really a matter of being able to remember how to solve differential equations. Part C asks to find the particular solution y equals f of x that you found in Part B here, and to find the limit as x goes to infinity of f of x. Even if you didn't get the correct answer in Part B, it doesn't matter, you won't lose points in part C, and in fact, if you just plug in and solve correctly for whatever equation that you got in part B, you can still get the point in part C. This is a very simple limit problem where we take the limit as x goes to infinity of 1 minus e to the 1 half minus 1 over x. And all we have to do in this case is plug in infinity for x, which leaves us with 1 minus e to the 1 half, and since we know 1 over infinity is essentially 0, then we can just have 1 minus e to the 1 half, which is also 1 minus the square root of e. That's a pretty simple problem. One thing is, if you see something like this on the multiple choice part, you have to be aware that this could come in a variety of different notations.